Hello and welcome to 5-Minute Math. Today we are looking at third grade readiness practice 3.2a. We're looking at composing and decomposing numbers, and this is at the proficient level. If you're interested in looking at the intermediate level or the advanced level or readiness practice for any other standard, you can do so by using the link in the video description. So our first practice problem talks about Farmer Fred has a massive pumpkin patch, and we have a total of 36,208 pumpkins, and we need to show that in three different forms. So let's write our number first. So I've got 36,208. So I want to put the value of each of these numbers underneath it, because that's going to help me as I choose here. So the 8 is in the ones place. I don't have anything in the tens place. I just have a 0. In my hundreds place, I've got my 2, my 6 is my thousands, and then my 3 is my 10,000s. All right, so that's my place value chart. I only need to select 3, but let's go ahead and put all 4 of these here. So if I wanted to do a word form, so what I would do is I would write it like I read it. Now I have to read it correctly. So first what we have to see is that this is broken up into periods or families. So the comma separates each period or family, and this period or family is actually the thousands period. And then the other one, we don't really say its name, but it's the ones period or family. And so what we want to do here is we want to say the name of the family after we've read that number. So for example, 36. That's that number. If we just pull out that number 36, stopping at the comma, and we say the name of the family or period. So 36,000. And then we're going to still put that comma there. Now we don't necessarily say the name. We don't say 208 ones. We just say 208. 208. But that's how we say in word form and verbally what these numbers are. So it could be up in the millions or the billions. You just take each set of 3 numbers, say what that is, including hundreds if you need to, and then the name of that family. We're not going to say anything for the tens place because there's nothing there. We're not going to say 208. We're reserving the word and for when we get into 4th and 5th grade and we start dealing with decimals. All right, so unit form is going to take the value that we have in each digit, starting with the largest again. So let's take a 3. I've got 3, and then 3 what? Well, let's just write that out. 3 10,000s. So this is unit form, and then you just add them all together. I've got 3 10,000s. How many thousands do I have? Well, I have 6 thousands. I have 2 hundreds. Now, I'm not going to put anything for my tens. I don't have anything, so you don't add 0 tens. You just leave space for the 8 ones, and there you go. You have that. Now, expanded form and expanded notation are going to look similar. Expanded form is something that we've done in 2nd grade. Expanded notation is new to 3rd grade. So let's look at expanded form. You write the value of each digit in that place value. So starting with the largest place value, that 3 10,000s is 10,000, 20,000, 30,000. So that's worth 30,000. And then the 6 thousands, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000 is worth 6,000s. 200s, 100, 200. We're once again going to skip the 0 because there's nothing there. And then we're just going to put the 8. Expanded notation is going to be similar, but you're taking the digit in each place value and then you're multiplying it by the value. That's why writing my place value chart is going to be helpful, because I'm going to write 3 sets of, or 3 groups of the place, 10,000. So 3 10,000s, if we look how it lines up here between the unit form, the expanded form, and the expanded notation, 3 10,000s is the same as 30,000. It's the same as 3 times 10,000, because you can do multiplication for repeated addition. All right, so I've got 6 sets or groups of 1,000. I've got 2 sets of 100. Notice I am adding still each of my products. Now, when we get down to 8, we're not just going to write 8. This is actually 8 ones, so we need it to be 8 times 1. So that is how we would answer this question. How can Farmer Fred write his number in 3 different forms? I wrote all 4. Just check to make sure you have 3 of yours. Moving on to the second practice problem. We are at a local zoo, and we have quite a bit of entries, 96,809. We want to show the number of entries as a sum of so many 10,000s, thousands, all that. So I'm going to use unit form for that. And look at this. For one of your answers, create a sum with no 10,000s. All right, so that's going to be a challenge for us. So let's write our number. We've got 96,809. I want to use a place value chart to keep things straight. And once again, I'm just going to put the values underneath. I find that helpful, especially if we ever need to get into expanded notation. All right, so how could I write that as a sum of so many 10,000s, thousands? Well, if we go back and look at the previous one, that's really what we're doing for a unit form. So there are 3 different ways that we can do this. And so what I'm going to do is I'm going to go ahead and put down at the bottom, answers may vary. So I'm going to show you multiple ways, but yours might differ. As long as they add up to your answer, you're good. So let's start with the easiest one, right? So one way that we could do it would be 9 10,000s, and I'm going to add them up so like I would in unit form, plus 6 thousands, plus 800. So I'm just taking the digit in each place value and naming the place value it's in, plus I'm not doing any 10s, there's nothing there, 9 ones. Okay, so that could work. Now, for one of my answers, I need to create a sum with no 10,000s. So let's go ahead and get that out of the way. How could I do this without any 10,000s? Well, one way is to visualize, and I'll put this in blue right here. If you take this as a chunk, instead of 9 10,000s and 6,000s, and visualize it as 96. So 96 what? Well, when you put these two together, you always need to see where the last digit is sitting. And the last digit is sitting in the thousands place, and that makes sense. 96 thousands is the same as 9 10,000s and 6,000. So I'm going to write 96 thousands. Think about it. If you take $1,000 bills and you count out $96,000 bills, that would be the same as counting out 9 $10,000 bills, 10, 20, 30, 40, 50, 60, 70, 80, 90, and then $6,000 bills. So that's a different way that you can do this. So I don't need to add my 10,000s or my thousands. I still need my hundreds, my tens, my ones. And there's no tens. I'm going to skip that. I'm just going to go ahead and just complete this with 8 hundreds plus 9 ones. All right, so what is another way to do this? Well, I've already done that everyone is separate, so let's try joining more. I can't really join the 0 and the 9, but what if I were to join the 8 and the 0? Same thing. Instead of 800s, what if I had 80 tens? Well, if I were to skip count by 10 80 times, right? If I skip out by 10 10 times, that gets me up to 100. So if I do that 8 sets of that, well, that's 800. So that's going to work. So I can separate my 9 10,000s. If you want, you can keep it as 96 thousands. I'm going to go back to how it was. 9 10,000s plus 6 thousands. My second answer is the one that satisfied the challenge of creating a sum with no 10,000s, though there's a few different ways to do that as well. Plus, now let's bring out my 80 tens. If you wanted to, you could have written 809 ones. That would have worked. Plus 9 ones. All right, so these are 3 different ways that you can solve it. You need 3 different ways, but remember, answers may vary, but hopefully you kind of figured out the pattern, and you have either one of these or something close to this. Just check to make sure one of your answers has no 10,000s. That was my second answer, and I only included thousands. For our third problem, we are looking at what Milani has here. She has a mystery number. We need to write her number in a whole bunch of different forms. Well, let's first figure out what her number is. It looks like I've got ones. It looks like I've got hundreds. So it looks like we're just going to skip over the tens. I've got, or we're going to have ones, we're going to have tens, we have hundreds, we have thousands, and we've got 10,000s. Okay. So 8. All right, so I built it, but the way they gave us the digits in this mystery number was they gave it to us backwards. And so we had to build it from right to left rather than from left to right. So let's just write our forms. Standard form. I basically wrote in standard form. 87,804. I need expanded notation. Well, writing my place value chart the way I did makes it pretty easy. You just take the digit 8, you multiply it by its place value, 8 times 10,000, and then you add it to the next digit, 7 times its place value. You add it to the next digit, 8 times its place value, and we're skipping the tens. There's nothing there. And then we're going to add it to 4, but make sure it's 4 times 1, not just 4. Now we need word form. All right, so remember word form, we are writing it like it reads. And so this is my thousands period. And this is my ones period, or my ones family. So I'm going to say that the full number before the comma. So 80, use a hyphen there, 87. And then I say the family name, thousands, or 87,000. And then 804, 804 is 804. I don't say the family name. And we don't say 804. We're saving that and for when we get into decimals in 4th and 5th grade. So that's word form. And then I need expanded form. All right, so expanded form is going to be similar to expanded notation, but you're writing the value of what that digit is wherever it's sitting. So 8 in the 10,000s is 80,000. 7 in the thousands is 7,000. 8 in the hundreds is 800. Once again, we're skipping that 0 in the tens, and I've got my 4. Those are the 4 different forms that were asked for in this proficient problem. If you would like practice in either the intermediate or the advanced levels or any other standard, you can do so by using the link in the video description.